Now we're going to add and subtract fractions. So if we think about it, 3/7 is represented by this, okay, 3/7. 2/7 is represented by this. And so if we add them, I have the 3 from the first guy, the 2 from the second guy, so I get 5/7. So when you have like denominators, it's so nice because your Hershey bars are divided up into those numbers of pieces. And again, the top is the amount that you have. The bottom is how many pieces each Hershey bar is divided up into. So what we want to do is we need to keep the denominator the same because that's how much we're dividing our Hershey bars up into. So in this first one, I have Hershey bars divided up into 10 pieces. I have 3 of them, and one of them is 4. So if you think about it, this is how it's going down. There's my Hershey bar divided into 10 pieces. The first guy says I got 3 of them. Second guy says I got 1 of them. So I have 4/10. But I always want to simplify and divide out any common factors I can. And 2 goes into both. 2 goes into 4 twice. 2 goes into 10 5 times. And there it is, my final answer. How about B? Well, I got a common denominator, so I keep it the same. Add the numerators, so I have 6/4. And then I can reduce that or simplify it by dividing out a common factor of 2. 2 goes into 6 3 times, 2 goes into 4 twice. But then I think about it, it's an improper fraction. So 2 goes into 3 once with 1 left over. So I have 1½ Hershey bars, which makes sense. Now what about subtracting fractions? It's the same idea. I keep the denominator the same, but this time I'm taking away. Just subtract your numerators and you're done. So this example, 3 take away 1 is 2. Keep my denominators the same. Simplify where I can. 2 goes into 2 once. 2 goes into 10 5 times. Done. Okay, so what happens now when I have different denominators? Well, it's a problem because my pieces aren't all equal, so I don't know what to do. Well, da-da, enter finding a common denominator. Okay, so we're going to use our information that we already know about getting equivalent fractions, and then we'll be able to be golden, man. So here we go. So when I'm adding or subtracting, I need to get a common denominator. Now, a lot of times they'll do the least common denominator, okay? And that's great. If you can find one, fantastic. Go for it. But if you're having trouble finding a common denominator, just multiply the denominators together. So 8 times 5 is 40. Now granted, my Hershey bars are divided into 40 pieces, equal pieces, but it's going to allow me to add these fractions. And then I say to myself, self, what do I multiply by 8 to get 40? 5. So I also have to multiply the 3 times 5, so I get 15. Same way here. What do I have to multiply the 5 by to get 40? 8. So what do I have to multiply the 1 by? 8. 1 times 8 is 8. So now I'm golden, man. I keep the denominator the same, add my numerators, and I'm done. In fact, I'm simplified. I have a proper fraction, no common factors, I'm done. Let's do the next one. Same denominator, 40. 8 times 5 is 40. 3 times 5 is 15. And the same way here, 8 8. You're like, you just did that. I know, but I just reviewed it with you. So 15 minus 8 is 7. Keep your denominator the same. So 7/40. Now, adding and subtracting mixed numbers. There's a bunch of ways to do this, but I am going to show you the way in which you keep the fractions as mixed numbers as you do it, because the numbers get so large, it's really a lot harder to do it the other way. But if you need it to be done the other way by converting to improper and then adding or subtracting and converting back, your teacher can show you that way. But I want to show you this way. So here we go. I'm going to write this as mixed numbers. So what we're going to do is we're going to take care of the fractional parts first and then deal with the whole numbers. So we're going to pretend that this is my problem. So I'm going to get a common denominator, and yes, I can multiply 6 times 12 and get 72, but why not use 12? Because 6 is a factor of 12, so I'm going to use the bigger number. 6 times 2 is 12, 5 times 2 is 10. Ooh, 7/12 stays the same. So I'm going to add the numerators, 17 over 12, keep the denominator the same, and then I'm going to add my whole numbers up, and I get 16. So I type that into my Math Lab homework, and they're going to say, although your answer is equivalent, you still have an improper fraction in the problem. So this is what we do. We're going to take 17/12 and change it to a mixed number. So 12 into 17 goes once with 5 left over. So I'm not worrying about the 16. We're just worrying about this. So 17/12 is really 1 and 5/12. But I still have my 16, right? So altogether I have 17 Hershey bars and 5/12 of another one. Now you're saying, this is super long. It is a long process, but you can do it. Let's try the next one. 5 and 1/12. Take away 3 and 2/3. So we're going to get a common denominator, you guys. It's going to be 12. 3 times 4 is 12. 2 times 4 is 8. Oh, forget it. I'm having problems already because I cannot subtract 8 from 1. So this is what I do. I'm going to borrow a whole number. So borrow from the 5, I get 4. Now you're saying, okay, I'm borrowing a 1. So really what I'm borrowing is 12/12. So this becomes 13. 12 plus 1 is 13. Ta-da! So you're saying, basically I just add the denominator and the numerator to get the new numerator? And I would say yes. But that's really what is happening is I'm getting 12/12, adding it to 1/12 to get 13/12. Now when I go, I can subtract. I'll get 5/12. Yay. And 4 minus 3 is 1, and I'm done. Well, how about this next part, C? Running out of room here. 5, take away 2 and 1/3. Well, you guys, I cannot take 1/3 away from 0. So I'm going to borrow from the 5. And I'm borrowing 1. But the form of 1 I want to use is with a 3 on the bottom. 3/3. So exciting. And 3/3 take away 1/3 is 2/3. 4 take away 2 is 2. So 2 and 2/3. Done. Now you're going to be able to do the lesson associated with the addition and subtraction. Hang in there. You can do it.